we are looking at this question, and this is case 4. We are looking at case 4, and what happened in case 4? Case 4 is a case of having repeated irreducible quadratic factor, and we have a question here. We have a question here to buttress that, to explain that. And if you look at the question, we have find integral of this fraction. Observation 1: the numerator power, the highest power of the numerator is power 3. Okay, the highest power of denominator here is higher than that of what? Numerator. So in this case now, what we are concerned with the denominator power. Okay, the quadratic here, the quadratic expression here, x squared plus 1 is repeated 2 times. Okay, and this quadratic expression is unfactorizable. We can reduce it. Okay, that's why we call it irreducible quadratic factor. So what do you do in this case? It's very simple. The step 1, solve this fraction using partial fractions. Then after that, we do the integration. So this will be equal to, this one will be equal to a over this one, followed by the second one, which is a quadratic, and that will be what? Bx plus c all over the quadratic expression. That's the first one, which will be power 1. This will be power 1. And the next one will be equal to what? The constant stop at c, that will be dx plus what? Plus e all over x squared plus 1, 2, power 2. Multiplied to by the common factor. The common factor is the this one times what? Times this one. So that's the common factor. So multiply through by that. Okay. So we're going to have on the left, we're going to have the numerator equal to this one also times the common factor. So it's going to give us a times x squared plus 1 all squared. Then this one also times the common factor. So we're going to have plus bx plus c times this one, x squared plus 1. Don't forget that this is a double, x squared plus 1 squared. This is 1 here. So this and this will cancel, so it will remain of this. Okay, and then with this also times the numerator, and that's what we have done here. Okay, then plus the last part here times the common factor. So we have this times this one. So what we need to do now, substitution will not help. It will not work here in this case. Okay, it's going to waste our time. We're going to expand and equate our coefficients. Okay, let's have the right hand side. Let's undo that. So that will be equal to a times x squared plus 1 squared. It's going to give you x to the power 4 plus this one times this one. That's x squared times 2, then plus what? Plus 1 squared. So that one is done. Then plus, can we expand this one? Let's have this one. This one times this one, that's s cubed. X also times 1 plus what? Plus this. Okay? So we're going to have this one, s cubed times bx. That's bx to the power 4 plus s cubed times c. That's cs cubed. Then plus x times bx. That's bx squared. Then x times c, that's plus what? Plus x. Okay? Then plus this one times this one, that's dx squared. Then x times e plus what? Plus ex. So that's what we have now. So let's open these brackets. Let's open these brackets. So we're going to have now ax4, this one times this one. Okay, done. This one times this one, that's plus 2a x squared. A times this one, that's a plus a. Then plus bx4 plus the remaining one we have here. So let's arrange the terms together. We have x4 here. We have x4 here. We can bring it together. That will be a plus b times x to the power 4. So that's this one and this one. For the cube, we only have one, that's a cs cube. And then for the s squared, we have one here, that's a 2a. We have another one here, that's a plus b. We have another one here, that's a d plus d times what? Times s squared. Then we can go for coefficient of x. We have that. So plus, we have one here, c plus e times x. We do have the constant terms also, so that's a plus a. So let's begin to equate the coefficients. So I'm going to start with the coefficient of x to the power 4. For x4, coefficient of that, on the left, we don't have it, that's 0. And then on the right, we have a plus b. Okay? And then for s cubed, the coefficients on the left is -1, and then here we have what? C. So C is equal to what? -1. Can we also do for s squared, coefficient of that? On the left we have 2 equal to, on the right we have 2a plus b, and then plus what? Plus d. We'll come back to this shortly. Then the coefficient of x on the left, we have minus 1. We have minus 1 equal to c plus what? C plus e. So we can quickly work on this. We know the value of c, so that will be equal to what? This equation, we can work on that. Minus 1 equal to c is minus 1 plus what? Plus e. So e is equal to what? E is equal to 0 if you move this one to the other side. So making two values we've gotten. Okay, for the constant terms, on the left is 1, on the right we have a. So a is 1, a is 1. So with this now, a equal to 1, you can come back to this equation and substitute there. That will be equal to what? 0 equal to, my a is what? My a is 1, 1 plus b. So b is equal to what? B is equal to minus 1. Okay, so we have the value for b now, we have the value for a now. Then we can get d from this equation. So from this equation, my a is what? My a is 1, that's 2 times 1. My b is minus 1, then I can get my d plus d. So I'm going to have now 2 minus 1 plus d. So that will be equal to 2 minus 1 is 1. So moving to the other side, that will be 2 minus 1 equal to what? Equal to d. So d is equal to what? D is equal to 1. So we've gotten all the parameters. Okay, then we can begin to substitute back to the equation. The question is this. Okay, so this is equal to what? Integral of a. My a is what? A is 1, so that's 1 over x plus. Don't forget we have bx plus c. Okay, all over what? S squared plus 1. Okay, my b is what? B is minus 1. My c is also minus 1. So this place will change. Minus here. My b is minus 1, and then my c also is also minus 1. So we have that. Then plus, don't forget the expression. That's a d x plus what? Plus e. So d is what? D is 1. E is what? Our e is 0. So that one is gone. All over x squared plus 1 all squared dx. So that's what we have now. This expression is equal to integral of 1 over this dx. This one, you can split into 2, and that will be equal to what? That will be equal to minus x over s squared plus 1 dx, and then minus 1 integral of s squared plus 1 dx. Okay, then the final one plus integral of this over s squared plus 1 all squared. This one, integral of this, I think we can explain this. Okay, integral of this will be equal to let's u be equal to s squared plus 1. So the u is equal to 2x dx. We can make this one the subject. So we have the u over 2 equal to what? X dx. Okay, so we can go back to this question integral. So we have the u 1 over 2 here equal to what? Equal to u squared. And that will be equal to half integral of u minus 2 du. And that will be equal to 1 over 2. Integral of this one will be what? Minus 2 plus 1, that's minus 1, or minus 1. Okay, so we are having minus 1 over 2, and then times 1 over u. The final answer will be ln x minus half ln x squared plus 1 minus arctan x, and then minus half times 1 over u. And where u is this. So don't forget here plus c. So what we just need to do is just to come back here and plug in your u. So we now have this as a final conclusion. Yeah, and that finished the solution to the question. If you're new on this channel or you are a returning viewer, kindly smash the watermarks on this video and subscribe. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.